In UniFi network controller, if you go to security setting under ACL rules, you can define two types of ACL rules, MAC ACL or IP ACL. They look very similar. You may think, okay, the only difference is one applies to MAC address, the other one applies to IP address, right? But is that really the case? In this video, let's talk about that. In this simple lab environment, I have one UniFi switch, 3 Linux clients. 2 of them are in VLAN 10, the other one in default network. So let's start with IP ACL. For example, if I want to prevent the communications between device 1 and device 3, they are in 2 different VLANs. Let's see whether we can use IP ACL to achieve that. In network controller, let's go to IPv4 ACL rule. Block device 1, 2, 3, and then the action, of course, is block. I want to apply to all switches, protocol, or the source. Pick one IP address only because I don't want to isolate VLANs. I only want to isolate the 2 devices. So let me put the IP address for device 1. Then for destination, similarly, IPv4 address, put the VLAN 1 IP address. Okay, very simple, right? Successfully created. It's effective. Then let's test it. From the left side VLAN 10 machine, let me ping the right side VLAN 1 machine. Okay, it's not pingable. So the ACL rule works, right? And then let's try to proceed within the same VLAN 10. I want to block the communications between device 1 and device 2. So similarly, create a new entry, IPv4 IP rules, block device 1 to device 2, source device 1 IP address, and the destination device 2 IP address. Okay, add the rule. See, there's an error, unable to apply changes. Unfortunately, it doesn't tell you why. That's something Ubiquiti needs to improve because the error message is confusing. But anyway, we cannot add such a rule from the web interface, right? I don't want to give up. I want to try from CLI whether I can add such rule and whether it works. So let's switch to command line. Let's first remove the previously created IP ACL rule so that we have a clean environment to start with. Remove it. Okay, now in the SSH session, let me log on to the switch. Telnet to itself, en for enabling, config, show IP access lists. Okay, no ACLs are configured. We are good to proceed. So let me create the first list with this name. You can see the prompt is changed. Now we are in the IPv4 ACL configuration mode. Then define the first rule. I want to isolate the device 1 and the device 2. This is the source. What I'm saying is this IP address with this mask. And then the destination is this IP address with the same mask. That's the first deny rule. Done. For the second rule, I want to permit all other traffics for this particular access list. So let me say permit IP NA to NA. Okay, the second rule is created. Exit the IPv4 ACL config mode. At this moment, we only created a list, but it hasn't been associated with any interfaces yet. So then let me run this command. So what I'm saying is I want to configure the IP access group with the name I just created, and the direction is inbound, and it will be applied to all interfaces for that switch. Done. Just to make sure the ACL is created and effective, let me show the current IP ACL. Okay, now you can see the one we just created, and then let's display the details. See, it has this name. It applies to all the interfaces. It's a deny rule. It's IP protocol, and the source IP address is this one. See here, the wildcard mask is the inverse mask if you compare to the one we created in the command line. It makes sense because all 0 means I simply want to match this IP address exactly. And then for destination, yes, this IP address, the same mask, right? And then the second rule is simply permit any to any. Okay, looks good. In the whole process, there's no any error message returned by the system. It seems the ACL is effective, right? But let's validate it. In the right side Linux, run it. Okay, it's not pingable. That means this IP ACL within the same VLAN does work, right? And to confirm that from the right side, let me ping the left side Linux. It's also not pingable. And to double check, let me remove the IP ACL from the backend CLI. I will keep these two ping sessions working here. Let's see whether they will be able to communicate each other after I remove the ACL rule. I will say no IP access list. Okay. See, right after I ran this command, no IP access list, the ping sessions work in both Linux. So that means they couldn't ping each other simply because of this ACL rule, right? We see different results from the backend CLI and the front-end web interface. My theory is IP ACL does support the isolation of devices within the same VLAN, but Ubiquiti want to avoid the too many options confusion to the end user. So Ubiquiti wants the end user to use MAC ACL to do that. That's why this function is disabled in the UI, but it hasn't done a great job. So it returns a very confusing error message. That's my theory. So if you have other thoughts, please let me know in the comments. So let me summarize. We tried the web UI and CLI for IP ACL. We confirmed for both cross VLANs or within the same VLAN, the IP ACL works. A obvious shortcoming for IP ACL is about the IP address for a device. You know, nowadays most devices get their IP addresses through DHCP. The allocated IP address may change. Yes, you may say you can give a device a fixed IP address. For example, in UniFi network controller, you go to a client, you can give it a fixed IP address, right? But you also know from the client side, for example, this Linux client, I can configure manual IP address. It doesn't go through DHCP. So then the UniFi router won't have any way to prevent a device from changing its IP address. So that means the IP rule can be easily worked around. We'll hear the MAC address, which is based on the hardware MAC address of the network interface. You may think it's a brilliant idea. It's a perfect solution to the shortcoming of IP address, right? Unfortunately, you may be disappointed. Let's look into MAC ACL. We have the same 3 Linux devices, the same 2 VLANs, VLAN 10 and the default network, the same switch. And I have cleaned up the environment. Now we don't have any ACL rules for the switch. At this moment, if I ping device 2 from device 1, of course it's pingable, right? Then let's start with the first deny rule. Go to network controller under security ACL rules. I select MAC ACL and name it as deny device 1 to device 2. Action is block all switches, and here interestingly it asks you a VLAN. We will talk about why you need to select a VLAN, but for now let's select VLAN 10. For source, let me choose MAC address, input the device 1's MAC address because I want the MAC address to be matched exactly, so I don't need to input net mask. For destination, MAC address, and this is MAC address for the device 2. I'm good. Add rule. Okay, it's successfully created. In the lower part of the screen for both Linux devices, I launched Wireshark and started capturing. So now nothing happened yet, right? From the device 1, let me ping device 2, and I only want to ping it once so that we have less packet to analyze. Start ping. Okay, see the ping failed, right? Then let's see what happened. Stop capturing. So from the device 1, it needs to know the MAC address for the destination IP address. That's ARP. It needs to broadcast. So from the source MAC address to a broadcast. And see the right side, it did receive the broadcast. The broadcast destination is not denied, right? We only denied the device 2's application in the MAC ACL. So the device 2 can still receive the broadcast ARP message. And then it did reply. So the reply is to device 1 about its MAC address, right? So from device 2 perspective, nothing is wrong. But from the device 1 perspective, see, after sending out the broadcast, it did receive the reply from device 2. This packet may surprise you, right? You may think we already denied the communication between these two. How can the device 1 still receive the ARP reply from device 2? Because the MAC ACL is directional. We only denied this direction, not the other way. So device 1 is still able to receive the ARP reply from device 2. That's why we have this second packet received in device 1, right? So far so good, no problem. And then for the third packet, the device 1 knows the MAC address for the destination IP address, so the ICMP packet was sent out. See the right side, it never received the ping. Why? Because if you check the ICMP packet, you can see the destination has this MAC address, and this MAC address is denied by our MAC ACL. Even though the device 1 is able to know the device 2's MAC address through ARP, it won't be able to successfully receive ICMP reply from device 2. Okay, let's try the other direction. So I already restarted the capturing. This time, let me ping device 1 from device 2. Okay, see, this time the situation is different. So let's see from the device 2, it already knows the MAC address for the device 1 due to previous communication, right? So this time the device 2 didn't send out ARP, it directly sent out the ICMP packet. That makes sense, right? But from the left side, the device 1 did receive the ICMP ping message from the right side Linux. See the very first packet. Why it could receive this one? Because we didn't deny the communication from device 2 to device 1, right? But when the left side Linux replied the ping, because it already knows the MAC address, it directly sent out the ICMP reply. It didn't use ARP to get the MAC address, right? Which also makes sense. But see the right side, it never received the ICMP reply because we have this MAC ACL rule to deny this traffic, right? It's clear why if we ping device 2 from device 1 or ping device 1 from device 2, we see different situation, right? But for the same VLAN scenario, let me do one more testing, because when we tested the pings, both Linux machines already knew the MAC address for the other Linux machine. Let me reset the network connection so that the ARP table can be refreshed. Now the ARP table should be cleared for both Linux. Then from the right side Linux, ping the left side Linux. See, this time you see different behavior. Remember last time when we pinged device 1 from device 2, it did send out the ICMP packet, right? But this time, because it doesn't know the MAC address for device 1 yet, it need to broadcast the ARP request, ask who has the IP address for the destination IP, right? But because we denied the communication from device 1 to device 2, the reply from the left side never reached the right side. So that's why it keep broadcasting, keep failing, and then it never had a chance to even send out the ICMP packet. Okay, I believe after these two back and forth testings, you understand it doesn't matter whether the devices know the MAC address for the destination or not. The communications won't be possible if we have a MAC ACL rule to deny the communication if the two devices are in the same VLAN. Now let's talk about the same VLAN thing. Why we keep mentioning same VLAN? It's because that's how ARP works. See the example ARP broadcast? It's sent to the broadcast address for that particular VLAN. If the communication is not within a VLAN, there won't be this ARP packet. So that means the MAC ACL cannot block the ARP packet. But whether the MAC ACL still blocks block the direct communications between the two devices. Let's validate it for this scenario. If we want to deny the communications cross VLAN using MAC ACL. Let me create this MAC ACL rule. Create entry, deny device 1 to device 3, actions block all switches, VLAN 10, source for device 1, destination for device 3. Add rule. There's no error, right? So it's effective now. Then from device 1, let me try to ping device 3. It is still pingable. And from device 3, let me ping device 1. Pingable. This MAC ACL rule doesn't prevent the communications between these two devices at all. To understand what happened, let's do Wireshark capturing. So now something's happening in the right side Linux, but it has nothing to do with our testing, so we can ignore it. In the left side Linux, ping device 3. Okay. It's done. Let's investigate what happened. See the left side from the device 1 IP address to the device 3. It sent out ICMP. In the right side, it did receive the ICMP. Why it received it? Let's check the packet. See the source is the device 1's MAC address, right? But let's see the destination. Why it's Ubiquiti? And this MAC address has nothing to do with our device 3's MAC address, right? Why is that? In fact, this MAC address is the UniFi router's interface MAC address. Why is that? Because these two devices are in two different VLANs. The traffic has to be routed through the router. So that's why the device 1 is not directly sending the packet to device 3. Instead, it's sending the packet to the router and hoping the router can route the packet to the destination, right? In Wireshark, you can see in the ICMP ping, the destination is the router. And because we allow this type of traffic, this packet was successfully sent to router, and the router successfully forwarded to the device 3. That's why you see it in the right side. See, when the right side reply, let me expand the Ethernet packet. See, the source is the MAC address for the device 3, right? But destination is the Ubiquiti router again. Of course, this one would be successful, and then when the router receives the ICMP reply, it will send to device 1, and that's why the device 1 received the second packet. See, what's the source? The source is the UniFi router, and the destination is the device 1. These communications were completely successful, and our MAC ACL rule was not effective in this scenario at all. Okay, and of course, if we ping device 1 from device 3, we will have a similar situation. So as you can see, in the whole process, it has nothing to do with ARP, and the communications are not directly between these two devices. So that's why the MAC addresses are not as what you expected when you set this cross VLAN ACL rule. So that's why it doesn't work. I believe it's clear when it comes to when to use MAC ACL, when to use IP ACL, right? If you want to manipulate the communications within the same VLAN, you can use MAC ACL, or if you really want, you can use CLI to implement similar thing using IP ACL, but on front end, it's not supported. But if you want to do cross VLAN ACL rules, you have to rely on IP ACL. MAC ACL simply doesn't work. It needs to be associated with a VLAN, and it only works within the same VLAN. Okay, thanks for watching.